Video, we're going to use addition and subtraction to solve a couple of inequalities. And the rules for solving inequalities are pretty much the same rules one would use to solve equations. The difference comes in the symbols and in the solutions. So let's take a look. All right, our first one is n plus 3 is greater than negative 2. And we need to isolate n just like we would do if we were solving an equation. So we're going to subtract 3 from both sides. And 3 minus 3, of course, would be 0, and that would give us n isolated by itself. And we have to bring down our greater than symbol at this point. The most common mistake is students just write an equal sign. They forget about the fact that they're working with inequalities. Let's see, negative 2 minus 3 would be negative 5. So our solution set for this problem is n is greater than negative 5. That would include all numbers greater than negative 5. The first whole number greater than negative 5, of course, would be negative 4. So if we wanted to check our answer, we could substitute in a number greater than negative 5. Let's use negative 4. Is it true that negative 4 plus 3 is greater than negative 2? Negative 4 plus 3 is, of course, negative 1, and negative 1 is, in fact, greater than negative 2. So this inequality is true. We have a true solution for our inequality. The last thing we need to do is show a graph of this, of n being greater than negative 5. And that's what I'm going to do now. Pardon me. I'm going to draw a number line. Don't need a ruler. It doesn't have to be perfect. You want to put a couple of arrows on it. And we want to include 0 here, and we're going to put in negative 5, and let's just put in one more value. How about 2? As long as I put in the value that I'm starting with, the rest, I'm just sort of showing my progression on the number line. There's no rule about what those numbers need to be. Okay, once again, I want to point out to you that if the variable is on the left, the arrow shows us the direction in which the line should go, in case we forget. But we want to include all numbers that are greater than negative 5. So because it's greater than, we're going to use an open circle, and the numbers that are greater than negative 5 are to the right. So we're going to draw our arrow thusly. And we have solved and graphed the solution for the inequality n plus 3 is greater than negative 2. All right, let's do the inequality that we have on the right here, using addition to solve it. Y minus 2 is less than or equal to negative 1. I'm then going to have to add 2 to both sides to get y alone. All right. And we get y by itself, bringing down our symbol, less than or equal to, pardon me, negative 1 plus 2 would, of course, be 1. All right. So our solution for this, our solution set, pardon me, are all numbers less than or equal to 1. And we can prove this. Why don't we do it by using a number that's less than 1? Why don't we try 0 and seeing if that's true? All right. So if I substituted in 0 for y, I would have 0 minus 2 is supposed to be less than or equal to negative 1, right? That's our original problem. And 0 minus 2 would, of course, be negative 2. And negative 2 is less than negative 1. It's not equal to, but it is less than. So I know that this solution is true. All right. Same deal. I need to graph this now. So I'm going to draw another number line, thusly, and put some arrows on it to show it goes on forever. I'm going to take a couple of values, 0, let's use negative 3, and of course I need to show the number 1. All right. Now, because we're dealing with a less than or equal to, we're going to circle the 1 and fill it in. And it's all numbers less than or equal to this, so we're going to go to the left and draw in our arrow, and this would be a graph of the inequality y minus 2 is less than or equal to negative 1, or actually of the solution set. And that is how you solve inequalities and graph them using addition and subtraction.